Okay, this last video, there's a few things that we just need to talk about with some applications of actually using radicals. And one of those applications, the biggest application that you will see is the distance formula, okay? And what the distance formula does is if you have 2 points, we'll say x1, y1, and then some other point, x2, y2, okay? It finds the distance between those 2 points, okay? It finds how far you have to travel just going in a straight line between them, okay? And so what the distance formula is as follows. It says to find the distance, you take your 2 points, you subtract the y values from each other. So you do, normally they do y2 first, but it doesn't really matter what order as long as you're consistent. Y2 minus y1 squared. And then, oh, I think your book, I'm sorry. Let me fix this. I do think your book uses x's first, so let's do that instead. X2 minus x1 squared, and then plus y2 minus y1 squared, okay? Essentially, you can get this formula just using what the Pythagorean theorem. If you draw kind of in like a little right triangle here, these sides turn out being the lengths that you have right here. So essentially, this is just the Pythagorean theorem written in a different way, okay? And so the distance formula helps us find the distance between 2 points. So let's do an example of finding the distance between 2 points. So we're going to find the distance between the point 2, negative 5, and 1, negative 4. Okay. So how do I use the distance formula? I'm going to maybe continue this up here. Okay. So how do I find the distance? Well, I just plug it into the formula. Okay. So if you kind of think this is your x1, this is y1, this is x2, this is y2. Okay. And so your distance here is going to be, you're going to have a big square root of x2, which was 1, minus x1 is 2 squared. Okay. And then plus y2 is negative 4 minus negative 5 squared. Okay. So we just plug those in the formula and find the distance. So we get, well, when I do 1 minus 2, that's negative 1. It's still going to be squared. Plus negative 4 minus a negative 5. Minusing a negative 5 would be the same as adding 5. So negative 4 plus 5 is 1. Okay. And so we get the square root of negative 1 squared is just 1. 1 squared is 1. So our distance is the square root of 2. Okay. If you had like, for instance, the square root of 27 as your distance here, you would need to simplify that radical. So like, if I had ended up with the square root of 27 as my distance, I didn't, but I would think of what goes into 27. Well, it would be 3 and 9. And then what goes into 9? We've got 3 and 3. So 27 is 3 3s. So are there any perfect squares in there? Yeah, there's a 3 squared and a 3. So you could take out 3 square roots of 3. Okay, so when you're using the distance formula, this is just a nice place where radicals actually show up, because you're like, when am I ever going to see a radical in the real world? Well, it turns out distances between points, they show up really often, okay? And so that's why they're important. Okay, so you should be able to do the one homework problem on this now.